Hi everyone, welcome back to my channel. I hope you're doing great. In the previous video, we have explored the RAG components practically coding, including data loader, splitter, embeddings, and retriever. If you haven't seen that video yet, I've added the link in the description below. Make sure to check it before diving into today's topic. Now, in this video, we are covering one of the latest and most important feature of the LangChain, the LangChain Expression Language, LCEL. LCEL is the game changing for the creating advanced chain and workflow in the LangChain. Here is what we cover today. What is LCEL and why it is useful? The difference between simple chains and LCEL chain, and how LCEL chains works with the Runnable, and advanced concepts like RunnableParallel, RunnableLambda, and feedback. A practical example of LCEL chain in the typical RAG application. By the end of this video, you will have the clear understanding of how to use LCEL to build the efficient workflow for AI project. So without wasting any time, let's get started. Let's start with basic understanding of LCEL. LCEL stands for LangChain Expression Language, and it's designed to simplify the process of building a chains by making them compact, flexible, and powerful. LCEL stands for LangChain Expression Language, and it is designed to simplify the process of building a chains by making them compact, flexible, and powerful. Key benefits of LCEL. It allows you to create a workflow using the sequence of runnables. It supports advanced functionalities like parallel execution, custom feedback, and fallback mechanism. It replaces the traditional chains, now it is called legacy chains, with a more modern approach. If you are struggling with the legacy chain before, LCEL make it easier to build a complex workflow without writing a repetitive code. Now we will check the simple chain versus the LCEL chain. What are simple chains first? Simple chains are the sequence of action that process input data step by step. For example, you send the input to the prompt template. The prompt is processed by the LLM. The output is parsed into plain text using the output parse. Then what is LCEL chain? LCEL chains are built using runnables, which are modular components like prompts, models, retrievers, or parsers that can be changed together using the OR operation. The key difference is flexibility. Simple chain has a limited flexibility and LCEL chain has the highly flexibility. And in the execution order, simple chain has the fixed order, that left to right. Then LCEL chain has we can define our own custom orders. In the advanced feature, a simple chain there is no advanced feature, it is a basic, but LCEL chain has the supports parallel tasks, fallback, etc. Now you may get the question, how do LCEL chain works? An LCEL chain is essentially a sequence of runnables executed in order from left to right. Here is how it works. Input is parsed in the first runnable, the example prompt template. The output from the first runnable is passed to the next runnable, that is LLM. The final output is processed by the output parse. Now let's see how it works in the code example. Let's understand how LangChain Expression Language LCEL actually works. I will walk through some small example that show how to build the simple language translation chain using the LangChain and OpenAI. Let's get started. So first we will import the API keys and setups. So here first we will load our OpenAI API key from the .env file using the .env package. This helps to keep the sensitive info into like API key in outside the code. Next, packages. Now we are importing the main things from the LangChain, that is a prompt template to design the prompt, and OpenAI to chat OpenAI to use the LLM, and the string output parse to format the model's output. Next we'll define the components. Here we define the three main components for the LCEL chain. First is prompt. It's a template that with a placeholder called text while passing in input at the runtime. Then the model uses the OpenAI's GPT 3.5 Then parser. This is the simple parser that extracts the text output from the model. Each part is modular. You can reuse or replace this easily. Next, creating a chain. Now this is the key line. We connect all three components using the pipe operation. This system is a part of LCEL, LangChain Expression Language. It works like a pipeline. First prompt, then the model, then the parser. This makes the code super readable. Now we will call the chain using the dot invoke and passes input text. The placeholder text get replaced with how are you. So that prompt becomes translate how are you into the Hindi. The model processes this and returns the translation when we print the final output. So let's execute that. So this is the output. So that's how LCEL works in the LangChain. You are breaking things into smaller blocks, connect them with the pipes and run the chain. This is the clean, modular and production friendly. Runnables in LCEL. Runnables are modular components that can be used independently or they change together in LCEL workflow. Let's explore some of the key types of runnables. First is RunnablePassthrough. Simple pass-through input data through without modifying it, useful for debugging or placeholder in the task. Next is RunnableLambda. RunnableLambda wraps the custom function into the runnables, ideally for applying the custom logics or with the chain. Next, RunnableParallel. It executes multiple tasks simultaneously or parallelly, useful for runnable independent operations simultaneously. Next, fallback in LCEL. For example, when we are working in the language model, issues like rate limits or downtime can occur. Fallbacks provides an alternative plan by switching another models or workflow when the error happens. Let's see all this in the code example. So let's understand how LangChain Expression Language or LCEL makes the chaining prompt modulars super simple. I will walk through some of the code examples starting from the basics to going to all the way to the advanced cleaning. If you have any doubts in between or in between the code, just you comment below. We'll try to answer on the each and every in details. So as you know, first we'll import the OpenAI key and the packages. So first we'll loaded the OpenAI key using the Python OS module and the .env packages. Next, we'll define the module. We are defining the chat OpenAI class to load the ChatGPT 3.5 Turbo. Next, string parser. Here we are defining the prompt template. It will insert the politician name dynamically at the runtime, and the string output parse helps to convert the output into the clean string. Next, we will define the chain. This is the LCL magic. We connect the prompt, model and parse using the pipe operator. Finally, we call the dot invoke with the input. That's the simple LCL module as you seen earlier video. So let's see with the LCL with retriever. So now we are using the simple vector store. This helps to retrieve the context based on the query. So we are using the OpenAI embeddings to create the embeddings and Docker array in memory search for the vector store. So here we will give the some text and use the OpenAI embeddings to convert them into the vector. Then we use the as retriever to get the retrieve the objects. So some template will be. So this is the prompt. We'll use the retriever context and insert the question. Now we are using the RunnableParallel. This allows the both retriever and the pass-through question to work in parallel. This is more advanced LCEL chain. We are retrieving the data and answering the based on their context. So first it will execute a get question from the retriever, then it will use the prompt template, then it's the models and the output parse. Now you will see the same thing using faces. So here we are using faces, a powerful vector database that can handle more data efficiently. So now intermediate picker parts of the input directory. This way we can use the values like questions or language across different steps of the chain. Next, lambda function for the chain. We show a very simple chain here. RunnablePassthrough keeps the input as it is. Then we use the lambda to modify the output usefully for the faster experience. Next, we'll create the chain of chaining. First, create a chain inside the another chain. So first we get the sentence about the politician. Then we ask if they were positive for the humanity. This real power of the chaining. This shows the real power of the chaining. Next, last topic. Let's see, the code example is fallback. So here we are using the chat model, chat OpenAI. We are giving the some dummy GPT fake model name. If this chain is failed, then it will execute this using this chain. So we are using with fallback. So if this chain is got failed, then it will get executed this another chain. So let's see nested chain and with the custom function. The custom logic can be added like this. In the chain, we apply the functions dynamically before passing into the prompt. So let's see the multi-step workflow. We use the chain 1 to get the country of the politician, then use the results of the chain 2 get the continent. This shows how LCEL can manage the complex multi-step flows. And that's it. You have just see the LCEL from the basic to advanced with the practical example. LCEL chain in a typical RAG application. Let's see how the LCEL chain works in the real world RAG app example. First, you will import the query that what is the task decomposition. Then retriever fetch the relevant document from the vector store and format the combines the document's content into single string. Then the prompt templates generate the context awareness query. Then model process the query and generate the response. The output parse format the response into the plain text. This workflow ensures the accurate answers even when the working with a large dataset. Let's summarize what we have learned today. LCEL simplifies the chain created with the modular runnable connection by the OR operation. Runnables like RunnablePassthrough, RunnableLambda, RunnableParallel adds the flexibility to the workflow. The fallback provides the robust by switching the alternative to modular modules during the error. The LCEL chains are ideal for building the advanced workflow like RAG application. With these tools, you can now create the effective and scalable AI workflow using the LangChain. Thank you so much for watching. If you found this video helpful, please give a thumbs up. It really motivates me to create the more content for you. Don't forget to subscribe to my channel and hit the bell icon so you don't miss any episodes in the exciting Gen AI series. Now here is my question for you. Which runnable do you most interesting? RunnableLambda, RunnableParallel or Fallbacks? Let me know in the comments below. In our next video, we'll explore the LangChain memory concepts and how they can be used in the store in the context across the multiple interaction. Until next time, keep exploring, stay updated with all the things in AI. See you in the next video. Bye bye.